Okay, so welcome to the day 2's daily challenge. And today's topic is about the transformations of different functions. And we have 6 questions in total. So all the 6 questions cover the knowledge of the transformations of the exponential function, as well as the quadratic function, and also the vertical stretches and shrinks of the quadratic function. Okay, so let's see these questions, and there are some pitfall points within these questions, and some of you got it wrong. So let's see them together. Okay, so for the first question, the graph of y equals to 2 to the power of negative x plus 1 and plus 2 can be obtained by translating the graph of y equals to 2 to the power of negative x. A, B, C, D, what? So for this question, I think half of the students, more than half of the students got it wrong. So you all chose B. So B is not correct. Let's see why B is not correct. Okay. So first we know that the original function is y equals to 2 to the power of negative x. And we want to get to this one. So let's first see if we want to have the 2 negative x to the 2 negative x plus 1. So this is about moving right or left, right? Since it's changed the x value here. So how does it change the x value? So actually we have the negative x minus 1, right? So it equals to negative x plus 1. So we change the x by subtracting 1. So subtracting means I will change another color for the, so if it's moving right, then it's subtracting. And if it's moving left, it's adding. And here we change the x to subtract 1. So it's actually 1 unit to the right instead of 1 unit to the right, to the left, okay? So here is why like B is not correct. Okay, and then let's see. If we want to have the y equals to 2 negative x plus 1 into y equals to 2 to the power of negative x plus 1 plus 2, this is about moving up or down, right? So if it's moving up, it's adding. And if it's moving down, it's subtracting. Okay, so here we have plus 2. So that's moving up by 2 units. And so together, in order to have the original function converted into the new one, we have it first 1 unit to the right and 2 units up. Okay, so choice A is the correct answer for this question instead of B. Okay. So some of you got the B is not correct. Pay attention to the pitfall points here. So moving right or left only change the x, and don't forget the parentheses here, okay? Okay. I see Ethan in the chat box said, oh, so Yo-Yo said C is not C, okay? So this correct choice is A. And Nicole asked about why is it to the right when you are adding 1? So, okay, so this is the question that, about the transformation of the exponential function. So for this kind of translations, if you move right or left, you change the x value within the function. And if it's moving right, if it's moving right, then you need to subtract the x value by the units of the translation. And if it's moving left, then it's adding, okay? So the units. So you need to remember this. And this is also a very important knowledge point in the translations of different functions. So the same rules applies to, like, no matter it's quadratic or exponential function, okay? Okay, let's then see the second question. So the graphs of functions y equals to 3 to the power of x and y equals to negative parenthesis 1 over 3 to the power of x. These two functions are symmetric about ABC what? Okay, so this is actually a reflection of the exponential function. So let's see. If it's y equals to 3x, if it's symmetric about the x-axis, what function can we get? What new function can we get if it's reflecting over the x-axis? Any volunteer? You can type your answer in the chat box. Okay, so if it's reflecting over the x-axis, then all the y value, all the points on the original function, their y value would become the opposite one. So it's actually y equals to negative 3x. Okay, so A is not correct. And if it's reflecting over the y-axis, all the points, their x value would be the opposite one. So that's actually y equals to 3 to the power of negative x and equals to 1 over 3 to the power of x. So B is also not correct. It's actually the combination of A and B, so it's symmetric about the origin, okay? So first, we have the reflecting over the x-axis and then reflecting over the y-axis. So that's negative 1 over 3 to the power of x. So choice C for question 2. Okay, yeah, so you're correct this time. It's C. Okay, so most of you got this question right. So I will directly move to the third question. And third question is a combination of the translation and the reflection. So first, we translate this function to the left by 5 units. So it's left here. And then reflecting it over the x-axis. So first step, translation, second step, reflection. And so let's see, for the first step, we have it left by 5 units. So by moving left, we change the x value. We add 5, okay? And the second step, we reflect it over the x-axis. So all the y value becomes the opposite one. So that's y equals to negative 11 to the power of x plus 5, okay? Yeah, so the final answer is negative 11 to the power of x plus 5. Yeah, you're correct again, Yo-Yo. Good job. Okay, so this question is not hard, and I think most of you got it right for the third one. But also, like, it's very common that we usually have the translation and reflection together, okay, as this kind of questions. Okay, let's see the first questions. And for the previous 3 questions is the translation and reflection of the exponential function. So I just as I said before, the same rules apply to the quadratic function when we do the translation things. So if it's moving right or left, we change the x value. So for the left, we add. For the right, we subtract. And if it's moving up or down, we change the y value by moving up for adding and moving down for subtracting, okay? And let's see this question. That we have a quadratic function here, and it moves 2 units to the right, and then moves down 3 units. And we have the new equation, gx equals to parenthesis x minus 1 squared minus 4. Okay, so what's the values of b and c Okay, so for this kind of questions, we need to, first we have the gx equals to x minus 1 squared minus 4. And let's get back to the fx. How can we get back to the fx? So first we need to move up 3 units, right? So this is moving down here. And if we want to have the fx, we move up 3 units. So that's, we add 3 to the, oh no, it's not gx now. So maybe, let's say it's hx, okay? So hx equals to x minus 1 squared minus 4, moving up by adding 3. So it becomes x minus 1 squared minus 1. Okay, and then we need to move 2 units to the left, okay? So, right, from fx to gx, so left from gx to fx. And we have the fx equals to, so for moving left, we change the x value by adding 2. And then don't forget the minus 1 there. So it's x plus 1 squared minus 1. So that would be x squared plus 2x. Okay, so we have the b, which is equals to 2, and c equals to 0. So that's b instead of a, okay, Coco? Oh, Yo-Yo, sorry. So it's b. Okay, so this question is for the translation of quadratic function. So it helps us review the rows again, okay? Okay, then let's see question 5. So why we have the question 5 here is for us to better understand how we do the stretches and shrinks of the quadratic function, okay? So we have the quadratic function fx equals to x squared and gx equals to 1/2 x squared, okay? So let's see, we first need to fill in these blanks in the table, and then let's see. Okay, thank you for providing me with the fx value, Yo-Yo. So it's 9, 4, 1, 0, 1, 4, 9. Okay, and it's obvious that the symmetry of axis is here, right? So x equals to 0, y-axis, yeah, it's the axis of symmetry. Good job. And for the gx, we can know that the value is 9/2, which is 4.5, and 2, 1/2, 0, 1/2, 2, and 4.5, okay? And also y-axis as the symmetry. Yeah, thank you again, Yo-Yo. And now let's use the table to graph the quadratic function, okay? So first for the fx, we have the -3, 9, and -2, 4, -1, 1, and 0, 0, the origin, and 1, 1, 2, 4, and 3, 9. Okay, so we connected them. Okay, so this is for, so the blue line is for the fx. Let me change another color for gx, okay? So when x equals to -3, the value is only half of 9. So that's 4.5 here. And for -2, 2, 1, and 1, -1, 1/2, and 1, 1/2, 2, 2, and 3, 4.5. Okay. And let's connect these dots. Okay, so the green line is for gx. Okay, so we can see that from the graph. So for gx, it's a shrink from the fx by a factor of 1/2. And for gx to fx, it's a vertical stretch by a factor of 2, right? So that's why when they have the same x value, the y value of gx is only half of the fx. Okay, so that's for the graphing. And hopes through this question, you got a better understanding of the vertical stretch and shrinks, okay? And then let's see a question that combines the translation and the vertical stretches of the quadratic function. So we have the fx equals to x squared plus 4x plus 4. We move 2 units to the right and then stretches vertically by a factor of 2. What's the new equation? What's the new equation, guys? Okay, let's see. Yeah, so first we have fx equals to x squared plus 4x plus 4. Is it a perfect square, guys? So don't forget, we review about the quadratic function yesterday. And you do know the factorization, right? Here, it's a perfect square. Thank you, Nico. Yeah, so here it's actually the x plus 2 squared. Okay, and now why we convert it into the x plus 2 squared, since this would be easier for us to do the translation and vertical stretch, okay? So if we move 2 units to the right, we only change the x value. So this is the first step. So for the first step, we change like x plus 2. So since it's moving 2 units to the right, we subtract. And it becomes x squared. And the second step, we stretch it vertically by a factor of 6. So it stretches, okay? So we actually directly times a 6. So that's 6x squared, which is choice D. Okay. Okay, so yo-yo is not C, it's D, okay? So that's why we first have it converted into x plus 2 squared. That would be easier for us to do the calculation following, okay? Okay, so let's see, for all the 6 questions, they are not that hard. And the I think the only paid for points is the first question, that it's not B, okay? So don't forget, we only change the x value, not the negative x, okay? Okay, so that's for day 2, 6 questions. And I think we will move on to the geometry part from tomorrow till the end of the daily challenge. And I hope to see you tomorrow, okay, guys, for the congruent triangles. And I will send the recording to the WeChat group. Okay. Nico asked me about you wrote left adding and you added 1. So why isn't it to the left? Okay. Yeah, actually, I understand your question now, Nico. So pay attention here that even though for left it's adding, but actually it's negative x minus 1 within the parentheses here, okay? So it equals to negative x plus 1. So I actually do not add 1, but I actually minus 1 for the x. But I open the parentheses, so it's negative x plus 1. Yeah, Glad you understand that. So that's the pitfall points, okay? That's why most of the students got this wrong. So it's x, we change x, not changing negative x, okay? Yeah, you're welcome. Okay, and there are also Chen Hui in the room. Do you have questions? Yeah, bye, Nico. Okay, if no question, okay.